Right. Hello, everyone. Sorry for the delay. My name is Niklas Breuer. I'm a senior solution engineer at APIIDA AG, and today we will talk about basically central version control for your APIs, especially with a little focus on layer 7. But I think the basic ideas that we bring to the table are applicable for any API management solution that you can think of. We will record this session and we will place the recording later on our YouTube channel. So in case you want to show this to your colleagues or you want to review it again, you can do that later on our YouTube channel. So this webinar is part of a webinar series that we are doing at the moment. So we already had three webinar meetings already, where we talked basically about APIOps, and I will catch you up on that if you don't know immediately what we are talking about here. And today, as I said, we talk about version control. If you are interested for any of the other webinar series, you can see the titles on your screen at the moment and the dates. So if you want to register, please do. And if you find that one of those topics are interesting for one of your colleagues, please also refer them to us. All right, let's talk about APIOps. So APIOps is basically what we are talking about when we are trying to explain practices that come from DevOps, from normal software development, and include obviously version control. And if you apply both concepts, so working with a central version control element and also DevOps processes, and you are working in the API cycle or API management area, then we are talking about APIOps. So the basic idea, why are we talking about APIOps? Well, there are a couple of pointers that you want to follow here. So one is that APIs, or the amount of APIs and the amount of APIs needed to be published are increasing every year. So what it means is that you need to be flexible and fast in deploying new APIs. And for API management, for the API management layer, that means you need to connect more APIs from the internal network and make them publicly available for your customers and partners. And obviously, you want to react to any changes needed for those APIs, and you also want to be able to deploy features fast, right? And the basic problem is that you are always running through a process, and the process is the DevOps process, which means you are creating an API, you are testing it, you're deploying it, you are getting feedback, you plan changes and implement those changes, and then the whole circle continues. So you need a robust process for that. And we think that if we combine DevOps processes and GitOps for APIs, that you can be competitive and that you need it to be competitive for the market, right? So specifically, what are we talking to today? We are talking today about version controls, or to be more exact, version control with a Git-based version control system. And we will basically talk about those three questions. So basically, why should you do it? How do you do it? And what can we what can we do? So how do we help you, especially for layer 7 APIs, for the Broadcom layer 7 API gateway? So let's talk about the basics first. This is a lifecycle. This is what I described earlier already a little bit, which describes roughly the different operations that need to take place so that you have a working process, and obviously, if you want to be fast, you need a CI/CD process for that. And version control actually affects this lifecycle at 2 places, or no, sorry, at 3 places, which is create, test and publish, and manage. Why? Well, for the creation, obviously, you need to be able, especially in the field which change, where products changing so fast as in the API business, you need to keep an overview, right? You need to control change. And then you also need to be able to document at a central place what is the version that we are testing, what is the version that we are deploying. And you obviously need a place from where you can deploy, especially if the environment where you are usually working on and developing on is changing, and you need to define a certain state which might change all the time, right? And you need to define the state of all the different components and then put them together on a testing stage and then deploy them from that definition. So why Git? Well, the basic idea is obviously that the idea why you have version controls is that you can control your changes, right? Which means usually in a typical flow, you have certain branches which contain different versions of code, and you have a development team, and or you just a single developer, right? And someone wants to add a change to the state of your current product, and you need someone who is controlling and allowing that change. And this is what the basic flows are all about. There are different flows that you can use, obviously, but this is what the process is about. And an advantage of that is obviously that you will see changes. You can compare changes from different versions, and you have access to the versions before. So it also has the component that it is a system where you can, if you keep it clean, look at the history of versions and choose to deploy a specific version which is running. A prime example is if you want to roll back a change, because despite all the testings that you did, you have a version in production and things go wrong. You need to be able to roll back to the last version which existed, right? So, and you need the way of to do that. And one very quick way is if you have an automated process to just deploy the last stable version, or just select the prior version and deploy it, right? Obviously, another point is if you have different people working at the same time, especially if they're working on the same resources, there are bound to be conflicts. And the merging of different branches and working with different branches is what allows you to control those changes, and maybe also implement the parts which are good from one person, the parts from another person, without them colliding in the code, right? Or without them overwriting lines. So, and if we're talking about API management for that, like I said, services are created fast. You need to be able to deploy things fast. You need to be able to control things. And especially for the layer 7 API management platform, the problem that you have is that the built-in version control is local, but it's not central, which means that a version on one system can have a completely different version number on another system. And so obviously the elements that I described on the earlier slide are, can be mapped to API management as well. So if we're talking about, if you have not worked with a version control system, let me just show you 3 elements of that. So if we are talking about a basic process, we are talking about storing source code, right? This is what we store. We are storing, for example, class files. For APIs, we might store service definitions. We might store configurations about what HTTP methods are allowed, what private keys are used, what certificates are used for authentication or other authentication elements. We might store configurations depending on the specific stage and so on. And all of those are basically, if they are changed, you can commit this new, in quotes, code or this new configuration, and someone who is responsible for that can actually sign it off, and you can create a pull request, and that pull, then your changes are reviewed and then merged into the current state of the let's say of the master branch, where all your which defines what you deploy or what you test. The second question is actually, how do you store it? Because you have different options to store, especially a set of files, right? Where you could put an archive. An archive is not suited at all because it obviously compresses the files and it is the readable, right? Then there are, for example, let's say bundles which combine a lot of different things, like I said, configuration, certificates, and service definitions and so on, maybe into one file. And while that is nice in a way that you have everything in one file, so you cannot, let's say, lose certain elements, the problem is, of course, that if you do a review, as a reviewer, you need to see, oh, okay, so this is an element that changed. For that is in this context is fine. You look into another context, and it might be challenging. But still, if that is how your process works, that's fine. Another option is obviously that you split the different elements, like into different files, and then you can compare different files individually. And I can show you later how Git does that. And like I said before, there are different flows. So for example, there is a GitHub flow and the GitLab flow, and these are all flows which are basically telling you, so you have branches which are basically parallel development lines, if you want so, and you can merge them, right? But you can also develop in them in parallel and then merge them later. And the question is, how do you do that, right? What is the basic process behind it? If you're interested about that, there are lots of resources online. If you want any recommendations how to do that, we will get to that in a bit. How we would say you could manage that change actually. But if you are interested more in depth in processes, please feel free to contact us. Now, if we take all what we have talked about in the last 10 minutes, we take it to the Broadcom Layer 7, which is our special field where we are the experts in, then you might know that there is actually a version control system in the gateway, in the gateway, which has a couple of different features. So one is obviously that, as you can see in the top right screenshot, it stores different versions, and you can actually configure the amount. The default value is 20 versions, and for the 21st version, the oldest version is removed. But you can actually save specific versions which are not removed, even if they are the oldest one and there are more than 20 versions, which is if you save them with comments. So for example, a specific version which you know is working, you could put a comment there and you have saved it. And you can compare things like you see in the lower screenshot. There you see actually a change where a folder has been added with a certain compare expression, and another variable has been removed. One additional thing which is pretty nice is in the top screenshot you see on the left side in the first column you see a star, and that star marks the currently active version. And what you can do is, as I basically described after the system that I described earlier, you can set different versions active. And you can allow them to use that version, especially, for example, if you're working on something, but you want people to test on the same system at the same time, for example, stuff like that. So with that in place, actually, you might wonder, why are we advocating for Git, right? So because a lot of things that I talked about already are in place, right? Except maybe the central version control. So these are the challenges why we think you need a Git-based version control. So one problem is you have no inter-cluster version transfer. So what does it mean? It means that a version 64 on your development gateway, once it is deployed, cannot be or is probably version 2 or 3 on your testing stage, depending on how often you deploy your developed versions. And so a question that sometimes comes up with customers is, okay, how do I know which version is which, right? And what this usually comes to is checking timestamps and then seeing, okay, so this is the last timestamp before the deployment, so I guess this is the version, right? Which is still not, it's not optimal. Yeah. The other point is that the version control that I just showed you is always for a specific element. So let's say for the policy of service or for the policy fragment. It is actually not there for, let's say, changes in the configuration like cluster-wide properties or identity providers and so on, right? You cannot roll back changes that you made there, which you actually can if you push if you have a certain version in your Git version control system, and then you push the change, right? Because then there you see the change and you can manipulate the different versions. And obviously you can actually have a better control over the whole product, not just the individual elements, because you do not see a change across multiple elements in this version control system, but you do when you do a merge to your master branch, for example. So this helps you to keep actually your version a little bit more stable, even if things are changing. And one additional thing that we found is if you use the API, the RESTman, which is the API of the API gateway, which allows you to manage the API gateway, right? Which also allows you to export the service and all its dependencies. The problem with the bundles a little bit, and Broadcom has seen this as well, is if you do a push of a bundle and nothing changed, it will look like this. So this is a screenshot of a screen from GitHub, and it shows this where I pushed the same bundle twice, and you see there have been changes, and the change that you see is that the minute and milliseconds and so on of a timestamp is changing, because every time a bundle is created, when a resource is written into that bundle, there's a timestamp, right? And we thought about, okay, so this is not really optimal because this is noise when you are trying to review a change in your code. All right, now let me show you how we do this. So let's go into demo time. So the first thing that I want to show you is basically the whole setup. So I have two policy managers. This is the development environment, the IDE for creating policies. I have a service here called demo migration service, and which has a couple of elements here, right? It has a policy fragment, which is a dependency. It has actually in that policy fragment, it has an identity provider which it needs to authenticate against. Then it has the gateway dot elements are class-wide properties. It has a private key which is attached here, and it also has an encapsulated assertion. And now we need to version that, right? And I want to later push this over. And as you can see, I have certain elements here already. I will show you why in a second. So one thing about this is obviously always when you do a migration, always when you do version control, is you might have things that you do not want to change, things which are always there, which are used by multiple services, which we are calling actually shared resources. And those shared resources you might want to control as well. So for me in this demo is the demo authentication fragment, the demo logic, and also a couple of those cluster-wide properties and the IDP. No, sorry, the IDP not, sorry, but the encapsulated assertion here as well. So what do I do? We have a tool called the APIIDA API Gateway Manager. So this is a tool that has access to these resources over the mentioned RESTment, the management API. And what I can do now is I can actually define my own shared library. This is the concept of basically pushing certain resources to also like versioning them and pushing them to a repository. And that repository is then basically holding your, let's say, your standard definitions. And those standard definitions are then not overwritten, right? It is assumed they are there. I will show you how that works in a second. So I'm just selecting, for the sake of this demo, a couple of cluster properties. I will select an encapsulated assertions that I prepared for this, and I select the two policy fragments. And now I can push them to Git. So for this, I prepared a repository. So I already prepared, for the sake of time, prepared the access already. So what I do now is I am pushing shared library elements. And what this does in the background is it clones the repository, it adds files, and then it pushes it to the repository. So if I now refresh this page, you can see elements of that. And we actually did not put this in an XML bundle as it is usually done for the RESTman. We pushed it in our own format, which is actually showing you the different elements, for example, the cluster properties in a JSON structure. So for us, it is easier that way. We also remove the timestamps so that you can actually, if you do a change to this, you can do a compare, which shows you the meaningful changes. And you can see the policy definitions here as well. Obviously, they are in XML because this is the format in which the layer 7 APIs are written. All right, now what I can do is I know that this shared library contains elements which my service that I want to migrate are dependent on. So I will register that library. What I do is I click on APIs. I want to register an API from Git. And now I use just the same repository. I register this. And here you see the elements that are in that repository. And I can change the name. I change the name to demo shared lib. This is a shared library for my demo. Just this little description here. And so now I can see those elements, and I can actually pull them from the Git or push them, export them from the node and push them to Git, or I can actually pull them from Git and push them into a node as well. So, and now this library is in the list of my libraries and solution kits. You will find here things like, for example, the OAuth toolkit or elements of the OAuth toolkit, which you install when you use the OTK. And now I can actually register my service, which is on one of my test gateways here. So it is in the demo folder. It is this service. And now you see it here in the list. And what I can do now is I can check this one out, and I can put a requirement here and say, so if you want to deploy or version this service, you need to have this library. You need to have those resources on your gateway. And it also means if you push definitions to another repository, those elements are ignored because it wouldn't make sense to store them redundantly, right? So, and we can actually do that. So I prepared another repository, which is my demo repository. Actually, let me open another tab for that so that I can have them side by side. And now I'm copying the repository string. I'm selecting my credentials. I put the format. We can also store it as a bundle. I will not show you that right now because it doesn't help me with showing you what I want to show you now, but just saying that we could. And now I'm saving this. I'm checking the availability. So the repository is accessible. And now I will push the definition from the gateway to the repository. Just adding a commit message. You can see the process bundle is be created, and now we're pushing the elements to the repository. So this has been successful. I can show you here. And now let's look a little bit closer at what we have here. So we are seeing the actual service that I want to migrate. What you would usually see here as well are all the dependent elements. So for example, the policy fragments, which are integrated here. So for example, I'm not sure if it is referenced. No, it's not referenced in here. But it is in the for the mappings, and you would usually see the elements that you see in this folder. So those two fragments, you would see them as well here, and you do not see them. I can later push it as a whole and demonstrate that. And for the configuration, you see, okay, so there's a private key. This is actually something that you might want to also push to your library because you would not want to override the key every time. And there are also configurations for the service that we are storing in this repository here. And so if I want to actually migrate this, I can perform a migration for this service. I'm selecting a gateway. I think I will skip the indexing. So this is basically an internal mechanism. I don't need to index both gateways because I know the state they are in from preparation. So this will save us a little bit of time. So, and now you see elements which are going to be pushed. If you want to have more information about how this works, you can actually watch the last webinar or a dedicated video for that on our YouTube channel. So, and we see only the services here, and the private key will be mapped. So there is an already existing private key with the same ID on the target system, so we will not overwrite it. And now you see here for the requirements, there is a demo shared lib requirement, and it is found on target. So if we are looking at our policy manager again, you see this service is here, it is not here. And what I could do now is I could actually migrate it. So it's been done. I need to refresh this page. And we see the services here. And what we can see here also now is that there is a fragment. It has a definition inside. There is the encapsulated assertion. So this is fully functional now. So the references are there. There is no error message or something for that. And just like this, I have demonstrated you a flow how you could now manage change. And I will demonstrate that actually. So for example, I'm activating a already prepared change. So I set this active. What I changed is in the comparison is I added a policy fragment which loads the configuration for the route, and it also has an optional route which I could activate here. which now is using the variables which are placed here after loading the actual configuration, right? All right. So, and this change now can also be controlled. So I'm going back to my API, going back to my service, to the version control tab. I did a change. I know it works. So now I'm pushing this to Git so that I can store it, right? So I have a prepared change, edit config load fragment. And I could push it in a new branch as well, which I'm not doing here just for the sake of time. So let's have a look at the repository. Now you see just now there has been a commit, and the policy shows you the fragment which is not part of the shared library, which is this one. You see the definition here. And you also see more elements, so cluster properties, which is this is a cluster property which is called demo training configuration. You see the value here, and this is actually used for the fragment which loads a certain configuration that you can actually see here. And so if we are now looking at this commit, you can see the change that I made, and you will see there are no there is no timestamp or something. You will just see, okay, there has been no cluster property, it has been added. There was no policy, a policy has been added with certain configurations in it. You see that the private key has changed. The only reason for that is that every time with an export, the gateway for security reasons adds a passphrase and a salt, including timestamp to this encrypted string here, so it cannot be broken, right? And now you see a couple of more changes. So for example, the number of the version which I talked about earlier, I can see it here. So this is the new, I can now see, okay, so on the development gateway, it was number 19. Number 19 has been pushed. And a couple of other changes here, but no timestamps, as I said, which is actually what I want, and this is one of the strengths from using Git, obviously. So if we're doing now a migration, just want to show you that as well. We will use this again, and I will skip the indexing again. And now you see there is not just a service, but there is also a fragment, which already was there from a test that I did earlier, but now I can actually update it. I can update the configuration, and I can just perform this, and you see the requirements again. And with this, I have a clean separation between my elements, which should not change, right, which is my library, and the actual code of the product. And now I mentioned this is not just one service, but it is like a whole setting of services with different configuration dependencies and so on, where it's very difficult to have a clean overview over this just from the view of the IDE or from the view of the version control of each element, right? It takes a lot more time. It's way more complicated. So let me just perform the migration just to show you that it works. So everything has been completed successfully. I will refresh the page here and look at the service. And oh, did I refresh too early? Let me look at this. Maybe I did not use the correct gateway. I'm not sure. But anyway, what I wanted to show you is basically the ability of the version control. I probably just made a mistake here earlier. And with that, let's go into a quick recap. So what did we learn, or what I hope, what I want to have you learn today? So the version control over Git allows you to control your versions centrally. And I think I made the point why that is important. It is your single point of truth. It allows you to have complex workflows with multiple developers and teams. And there are multiple flows that you can use, and you need to check to find your own way, obviously, or maybe you already have it for software development and for API users as well. And I hope I showed you a little bit about what APIIDA can do for you with our Gateway Manager, but also if you need any expertise about managing your APIs with version control, we will gladly help you with that. So what's next? Well, if you paid attention earlier, this is a whole, or if you came later, this is a webinar series that we are doing here actually. So we just now completed part 4, which is about API version control. The next one will be about a CI/CD pipeline. So basically the idea of using deployment, using version control, having tests and so on, and putting all of that into a process which is automated. So the idea is that you are just managing the process, but you're not executing it. You are saving time and you're saving resources. Thank you very much for your attention. And I think I've seen a question. So let me have a look at that. So the question is, can Git be used to help silo environments? For example, eliminate spanning of environments. So I'm not, I give you my take on your question because I'm not sure I understand it completely. I think basically I answered the question already. So if we're talking about different environments like test environments, pre-production environments, production environments, and so on, obviously you can do that depending on your network infrastructure, and if you have access to the repository in each network segment, you might be able to access it directly, or you need to be creative. This really depends on your infosec. But what I think what I can show, or I showed you, and there is also a flow. I think it's called. I think it's the GitLab flow. So the GitLab flow is a flow where your stable version of your product is in your master branch, and then you have different branches for, let's say, testing, pre-production, production. And so you can basically you are creating those branches always when you have a stable version. And with this, you can basically say, okay, from this branch, I want to deploy to this environment, right? And if you have, you can obviously use the branching for your library as well. So if you want to actually deploy configuration, stage-dependent configuration that you changed or that you added to from your repository, you can create those branches as well. And then you can combine those elements. You're fine with deploying where you want to deploy. I hope that answered the question. All right, let's see. Are there any more questions? I don't see any. I'll give you maybe a couple more seconds. If you stop the webinar and you find that you have actually any questions, you can contact us over our website. You can also leave a comment below the video on YouTube. If you find you have any questions, feel free to contact us. We are glad to answer your questions. And with that, I will stop the recording. I thank you again for attending the webinar, and hopefully see you in the next one. Bye-bye.